An airplane is flying at an altitude of 6 miles and passes directly over a radar station. When the distance between the plane and the radar station is 10 miles, the radar detects the distance is increasing at 476 miles per hour. A diagram is shown. What is the speed of the plane? Okay, first let's label the distance between the radar and the plane with Z, the distance from the plane to the radar horizontally speaking, X, and the altitude, since it's constant, it will be just 6 miles, right? Now, notice that at any moment, the following should be true. 6 squared plus x squared should be equal to z squared, right? I have just used the theorem of Pythagoras, this right triangle, right? I got this. Next, we should take derivatives in both sides of this equation, right? Derivatives with respect to t of 6 squared, which is just 36, right? Plus x squared, and derivative with respect to time of z squared. Now, derivative of the constant function 36 is 0, plus derivative of x squared is 2x, right? But since we're taking derivative with respect to time, we have to attach dx dt, right? This is because of the chain rule. Next, derivative of z squared, that is 2z, right? But that's when you take derivative with respect to z. We are taking derivative with respect to t. So we're going to attach dz dt. Okay, so now it's time to replace the values that we have and figure out the values that we don't have, right? Such as this rate of change, dx dt, the speed of the plane, right? You can see. All right, do we have x? Well, we don't, right? So we're gonna just leave some space for x, right? Dx dt is what we need to find, right? Do we have z? Yes, we do. 10 miles according to the information given in our work problem, right? At that moment, when this distance is 10 miles, they want you to compute the speed of the plane, right? At that moment. Now, the speed of the plane is given as well. It says the radar detects the horizontal distance of the plane with respect to the radar is increasing at 476 miles per hour. The units are all comparable, so I'm not writing them, okay? So now I need x. What is x? When z is equal to 10, then I'm gonna have this situation, right? A new triangle. The plane is gonna be now here. It should be 10. This is always 6, altitude is constant, and I need to find x, right? So in this triangle now, applying the theorem of Pythagoras, 6 squared plus x squared equal 10 squared, not hard to figure out what x should be, right? So subtracting 36 in both sides, we get that x squared is equal to 64. And taking square roots in both sides, we get that x is equal to the square root of 64, which is just x, right? Notice I am taking just the principal square root of 64, the positive one, because I'm measuring distance, right? Distance cannot be negative. All right, so then that 8 should go here. 8. And basically, I have everything except for dx dt, which is precisely what I need to find, right? So dividing both sides of this equation by 2 times 8, what I get is the following. Dx dt twice 10, 6, all over twice times 8. Let's compute it. Okay. Two times 10 . I'm not doing this with a calculator. It is possible to do it using mental mathematics, but let's put our case ourselves, I would say, right? In worst case scenario, let's say the numbers are not that friendly, right? So this is what you should do in your scientific calculator. I got 595, right? So that should be the answer, 595 miles per hour, right? Since all the units were compatible. So that is the speed of the plane.